Okay, you see, pretty good amperes, right? Oh, super high current. I'm pretty sure that it can start a bike without any problem. Oh. So guys, as you can see that this UPS is very useful in our day-to-day lives. Look, I still have 11.8 showing from the battery inside and output of 227 volts. It's working just great, and with a metallic handle, easy to carry it around. Okay. Now this what you see is a water pump used in water purifiers, reverse osmosis RO pumps. Okay,
If you have such a damaged pump at home and you haven't thrown it already, then you are lucky. Others can find it from scrapyard as I did. So yeah, as you can see that the plastic head with inflow and outflow has been taken out along with the base stand of the pump. You have to hammer it and then the motor is separated from the water pump. You see, this is the shaft and that's the motor. Let's open up the motor to see what kind of motor is it, DC or AC. Okay, opening the head.
Wow, it's very nice, beautiful.
You can see the commutator and the armature along with the brush setup. This means that it is a DC motor for sure. And guys, the armature, commutator and bearings are pretty smooth and shiny. Although it was not that much good looking from outside, but it is as good as new from inside. Now comes the field magnets. You see, big concave magnets have been used, 2 poles. So it's a permanent magnet DC motor. You can see the field is still pretty strong, although more number of tones could be added on the armature to increase the pole strength. But anyways, let's try this as motor and generator and place it all back. Now guys, this is a dual size aluminum pulley. You can see screws have been provided to tighten up the shaft and it is an 8 mm pulley. Link for this has been provided in the description. You can check that out and if you want to buy it, you can go to the link in the description. You can tie it with the Allen keys that have already been provided to you with this pulley, and you can see that this pulley fits perfectly to the RO motor shaft. Okay, so here guys, I have placed the motor on the vise to test it in the generating mode first. Now these are the 2 jumper cables. Now guys, to the wires coming out from the motor, I have connected jumper cables. You see this light, it is a 12 volts 1 ampere light, meaning 12 volts. So I'm connecting this light bulb to this RO water purifier water pump motor. Okay, so let's wound the thread and see if it glows the bulb. And you can see that it is glowing bright enough. Let's turn off the light and try again. And you can see it is much brighter now. Now let's test the voltage rating of this generator. I mean, how much volts is it generating under hand rotation and after that rope rotation. Hand rotation voltage is very low. Let's test the rope rotation. Okay guys, as you saw that the output voltage was as high as 60 volts DC again. And now guys, as you saw that the voltage went beyond 100 volts. Guys, let's measure the current now, pointing the meter towards 10 amperes current mode and winding the thread. And you can see that the current rating was around 1.79 amperes. Try 2, second try, you can see it is 2.60 amps max I could try. Now guys, this is the mini UPS that I made in my previous video. So it also has a 12 volts DC output with which I'm going to run this motor first. Okay, you can see that it is running the motor and hence proving that the motor is a DC motor again. Now this is a 220 volts socket. I'm going to use the multimeter and the DC motor speed controller to run this motor at high speed with very high voltage, 230 volts AC, and then convert it to DC obviously with the help of a bridge rectifier. And I'm also going to connect a multimeter in parallel to the DC motor to measure the voltage at the same time when I have connected the terminals of the motor to the home socket supply. Now this is the knob, controlling knob, and the terminals from the jumper cable have been connected to the DC socket of the controller. Now let's turn it on. You can see that the motor has started running at a very high speed and the voltage is being displayed. And as you can see that the voltage is crossing 1500 or even 1600 volts. That is because of the inductance in the coils of the armature of the DC motor. The motor is running very fast. Obviously it is not designed to operate at such a high voltage, guys. Now guys, the BLDC hub motor has been perfectly connected to the vise. Now it's time to connect the BLDC motor controller no Hall sensor type. You can see there are only 3 cables and I'm not connecting the Hall cables. So this side is low and high speed and this is clock and anti-clock. This is a 32 volts DC supply from a printer adapter. And this is a multimeter, link for which will be provided in the description. You can see the output 32 volts DC and I'm going to mark positive and negative polarity. So with that being done, let's connect the BLDC motor controller. Positive to positive and negative to negative, red being the positive and black being the negative.
Second try. Okay. 9.64 amperes.
Hi guys, today in this video I'm going to make a 220 volts to 9 volts DC supply high current 20 amperes. So for that I'm going to use this UPS transformer. Now let's cut a wooden piece that is going to be required for this project as the base stand. Terminals of the rectifier to the low voltage high current side of the transformer, and to the DC terminals of the rectifier I have connected it to the capacitor, considering the positive and negative terminals properly. Okay, now the AC pin has been connected to the high voltage side of the transformer. Let's measure the voltage with the help of these jumper cables. You can see that it is glowing the car indicator bulb quite good. Now link for the jumper cables and in connector box will also be provided in the description, so don't forget to check them out. You can see that the voltage output of this setup is 9.15 volts, which is exactly what we need, 9 volts. Let's try and glow this 12 volts bulb with it, and as you can see that it is glowing pretty good. Yeah. Now comes the centrifugal pump, which is a 15 amperes DC shunt motor, 12 volts, General Electric. Now it takes huge current because it is a shunt motor. You can see how thick the cable is, and this supply should be able to run it. Also guys, polarity does not matters for shunt motors or any type of DC motors. You can see that it has started running pretty good even at 9 volts DC.